Isotopes. Isotopes are atoms of an element with the same atomic number but different masses. In science, it's important that you learn different chunks of the words, and you're able to break down the words into different pieces, because some of those pieces repeat themselves in many different science classes that you're going to take. So if we look at isotope, iso means similar. So knowing that iso means similar, you can then deduce the definition of this. Isotopes, similar types. So atoms that are isotopes are similar types. So what's similar about them? They have the same number of protons, but they have different numbers of neutrons. So the mass number is the sum of protons and neutrons, so the mass number would be different. Now down here, I know it's kind of small, but you can see your typical hydrogen has a mass number of 1 and an atomic number of 1. It just has 1 proton. But there are some hydrogens that have 1 proton and 1 neutron, or 1 proton and 2 neutrons. So the mass number increases. So isotopes are often symbolized in the following way. So we have the chemical symbol, the mass number on the top, and the atomic number on the bottom. So this is neon, and you can see that in order to be neon, it has to list the same atomic number, because elements are designated based on the number of protons in their nucleus. If the number of protons changes, then it's a different atom of a different element. So neon, 10, 10, 10, that's not going to change. But what makes this an isotope is the mass number changes. So here we have neon with 20. And neon with 20 is probably the most common form that you'll find. Then you have neon 21. So it's most common for neon to have 10 protons, 10 electrons, and then if you do the mass number minus the atomic number, you get the number of neutrons, so 10 neutrons. But there are some times where you'll find forms of neon that have 11 neutrons or 12 neutrons. All atoms of a given element have the same number of protons. As I just mentioned, they do not necessarily have the same number of neutrons. So atoms with the same number of protons but different number of neutrons are called isotopes. All elements have their own unique percent of natural abundance of isotopes. So again, naturally occurring, neon has 10 protons, 10 neutrons, neon 21, 10 protons, 11 neutrons, and neon 22, 10 protons and 12 neutrons. The relative percent of how these exist, 90% exist as neon 20, only 9.25% exists as neon 22, and only 0.27% exists as neon 21. So you can see these broken down. And depicting it this way is also a shorthand of indicating that it's an isotope. So any -20 is giving the symbol and then the atomic mass. And because we're giving the atomic mass, we are indicating the number of protons and neutrons in the nucleus. So the mass number A is the sum of the number of protons and neutrons. So the number of neutrons in an isotope is the difference between mass number and the atomic number. And as I mentioned, this is a different way of indicating, so you'd put the chemical symbol and the mass number. So neon 20, you can also write out the word neon and put -20. So there's different ways that we can indicate isotopes. Okay, I'm going to go through the first row here, and then I'd like you to pause the video and go through the second row and third row. So it says to complete the table. So we're going to start with this one, Cl. Now if you have your periodic table of elements handy, you know that Cl is chlorine. And now we want to know atomic number, mass number, number of protons, and so forth. So based on the shorthand of this, the atomic number is 17. The mass number is this number up here, and that's going to be 37. The number of protons is equal to the atomic number. So 17 is the atomic number. That's going to be the number of protons. The number of electrons. So we don't see a charge on this. We don't see 1 plus or 1 minus or anything like that on here. So because it's uncharged, the number of protons, which have the positive charge, has to also equal the number of electrons, which has the negative charge. Because to become neutral, the positives and the negatives have to be able to cancel each other out. So if there's 17 positives, there has to be 17 negatives. So the number of electrons is 17. Now how do we get to the number of neutrons? The mass number is the number of protons plus neutrons. We know that there's 17 protons, and we know that the mass number contains 17 protons plus however many neutrons. We just subtract the 2 to get the number of neutrons. So go ahead and pause the video and try to figure out the next 2, and then we'll go through the answers. Okay, hopefully you had a chance to work through those. We're going to start with this next one. So, the atomic number. Elements are listed on the periodic table by their atomic number. So if we want to know what the element is, we're going to find 82 on the periodic table. 82 is lead. And the symbol. So the symbol is created by putting the capital P, the lowercase b. So lead is Pb. Then we put the mass number on top and the atomic number on the bottom. So Pb, 204 goes on the top because that's the mass number, and 82 goes on the bottom because that's the atomic number. How many protons? The atomic number is the number of protons. How many electrons? Well, there's no charge on this, so the positives have to equal the negatives. So if we have 82 positives, we have to have 82 negatives. The number of neutrons. The number of neutrons is the mass number minus the number of protons. Okay, so now we're going to go down to this one. So this one we kind of work in reverse. The number of electrons is 18. So the number of positives have to equal the number of negatives. So if there's 18 electrons, there has to be 18 protons. And our atomic number would also be 18. Since the atomic number is 18, and elements are listed on the periodic table in increasing numbers, we know that number 18 on the periodic table is argon. Now to calculate the symbol, argon is Ar, so capital A, little r. Since there are 18 for the atomic number, we put 18 on the bottom. And then to find the number on top, the mass number, we're going to have to add the number of protons plus the number of neutrons. Now here it says there are 20, and then we know that there's 18 protons because it's a neutral atom. 18 plus 20 is 38. So you can see 38 on the top, 18 on the bottom, and here's our element symbol. 18 for the atomic number, the mass number is 38 and 18. So you may be given these bits and pieces of information on the exam, and you'll have to calculate protons, neutrons, and electrons. So take some time to review this table. We will also have some more examples at the end of this lesson. The atomic mass of each element listed on the periodic table represents the average mass of the atoms that compose that element. So it takes into consideration all of the isotopes that exist, and it takes an average. So 75.77% of chlorine exists as chlorine 35, and that has a mass of 34.97 AMU. And 24.23% exists as chlorine 37, which has a mass of 36.97 AMU. And if you remember atomic mass units, AMU, that's the unit that we use. So to calculate its atomic mass, you take the percent, so you turn this into a percentage, so divided by 100% gives you this, times the mass, plus this percent times the mass, and that gives us the average atomic mass of 35.45 AMU. So in general, to calculate atomic mass, we take the fraction or the percentage of the first isotope times the mass of that isotope plus the fraction of the second isotope or the percentage of the isotope or second isotope times the mass. And then we just continue. If there's another isotope that exists, we add that percentage. If there's another one, we add that percentage and so forth. So gallium has two naturally occurring isotopes. Gallium-69 has a mass of 68.9256 and a natural abundance of 60.11%. And gallium-71 has a mass of 70.9247 and a natural abundance of 39.89%. Calculate the atomic mass of gallium. So the first thing we have to do is convert these percentages to decimals. So we'll take 60.11 percent divided by 100%, and we get 0.6011. And that takes care of that one. Now we need 39.89%. We're going to divide that by 100, and we get 0.3989. So using the formula from the previous slide, we're going to take the percentage, 0.6011, times the mass, 68.9256, plus the percentage of the next one, which is 0.38989, times the mass of that one, which is 70.9247. And when we do this in our calculator, we're going to actually want to use those parentheses. So parentheses 0.6011 times 68.9256, close your parentheses, plus, next parentheses, 0.3989 times 70.9247, close those parentheses, and we get 69.7230 da 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 da. Now we were given problems that have a minimum of 4 sig figs, and since this is a, so you can see the 4 sig figs in these, that's the least number of sig figs, because these have, this one has 6 sig figs and this one also has 6 sig figs. So in order to round the answer to the appropriate number of sig figs, it would actually be 4 sig figs. But as I stated in this class, just to make everything simple, we can round it all to 3 sig figs. So 1, 2, 3, look to the right, and we're going to have to leave this 7 where it is because the next number is 2, and we just drop it. So 69.7 AMU is our final answer. Now if we look up gallium on the periodic table of elements, you can see the average atomic mass of 69.7, and that's what we calculated. And here the solution has been solved out for you. So carbon-14 dating involves measuring the amount of carbon-14 remaining in a fossil. How many neutrons does this radioactive isotope have? So remember, to calculate neutrons, we're going to take the atomic mass, the top number, minus the atomic number, the bottom number. 14 minus 6 is 8. Approximately 50.7% of all atoms of bromine are atoms. How many neutrons, protons, and electrons does this isotope of bromine have? Okay, so 44, 35, and 35. What is the mass number of an atom that contains 30 protons, 30 electrons, and 35 neutrons? So again, what is the mass number? Protons plus neutrons. The nuclei of some isotopes of a given element are not stable. These atoms emit a few energetic subatomic particles from their nuclei and change into different isotopes of different elements. The emitted subatomic particles are called nuclear radiation. The isotopes that emit them are termed radioactive. So when those isotopes are emitted, or when those subatomic particles are emitted as radiation, they have the ability to interact with our atoms, and that's why they're so dangerous for people. Now we can target this radiation toward different parts in the body, and we use that in order to kill cancer cells. So what we do is we implant these little metal chips into the center of the area where we want radiation to impact the cancer cells. And then we will hit them with the radiation, and the radiation will target toward the metal and essentially kill the nearby cancer cells. The problem with this is that the radiation doesn't have 100% effectiveness toward that metal electrode that we put in there. So there is some neighboring cells that get impacted by the radiation. So it is a dangerous process. Even though it gets rid of the cancer in that area, it still has the ability to impact neighboring cells. So there's a lot of cell death, and it can cause a lot of issues in the body, a lot of side effects from that process. Nuclear radiation can be harmful to humans and other living organisms because the energetic particles interact and damage biological molecules. Some isotopes, such as lead-185, emit significant amounts of radiation, only for a very short time. Other types of, such as Pu-239, remain radioactive for a long time, thousands, millions, or even billions of years. So radioactive isotopes are not always harmful, and many have beneficial uses. Technetium-99 is often given to patients to diagnose disease. The radiation emitted by this helps doctors image internal organs or detect infection. Okay, so this is a table, and this is like a similar problem that you may encounter on the exam. So I'm going to go through how to calculate, I'm going to go through magnesium down here on the bottom, because this one is a little tricky and we haven't really talked about what to do if there's a positive or negative charge on it. And then after I go through magnesium, I would like you all to pause the video, and then we will resume to go through the answers. So here we go. Magnesium. The atomic number is the number on the bottom, so that's 12. The atomic mass is the number on the top, so that's 24. The mass number is the same thing as the atomic mass, so we're going to put 24. So remember, the atomic mass is kind of the calculated average mass on the periodic table. So if we look up the actual atomic mass of magnesium, it's 24.305. And the mass number is that rounded. So 24 is our mass number. You can put the 0.305 to indicate that this is the calculated mass from the periodic table, or you can round it, it's up to you. Protons. So the atomic number is the number of protons. Neutrons. The number of neutrons is the mass number minus the atomic number. So we have 24 minus 12, and that gives us 12. Electrons. So in an uncharged atom, the number of electrons is equal to the number of protons. So if this were uncharged, it would be 12. But it's charged. So it has a charge of 2 plus, which means that it became more positive by 2. In order for an atom to become more positive, it has to lose electrons. Because remember, electrons have a negative charge. So you have to give up negativity to become more positive. So if magnesium usually has 12 electrons, but this magnesium has 2 plus, it means that it became more positive by 2. In other words, it lost 2 of those negatively charged electrons. So the electrons is not going to be equal to 12. It's actually going to be equal to 12 minus 2, because it's losing those electrons to become more positive by 2. So the number of electrons here is 10. Now if you become more negative, like you see As3 minus down here, if you become more negative, then that means you're gaining electrons. So if you become more positive, you're losing electrons. More negative, you're gaining electrons. Why are we only messing with the electrons? Why not messing with the protons? Because if we change the number of protons, we're changing the element from the periodic table that we're talking about. So we can gain and lose electrons. We cannot gain and lose protons. So if we are an atom and we want to become more positive, we can't just gain more protons. That makes us a different element. But what we can do is lose those negatively charged electrons. So go ahead and pause the video, work through this table, and then when you're done, you can unpause and I'll go through the rest of these answers. Okay, here we go. So we have this first one. Looking at the periodic table, we know this is hydrogen. It has an atomic number of 1. The atomic mass is 1.008. And the mass number is 1. It has 1 proton, 0 neutrons, and because it's uncharged, it has 1 electron. Here we have hydrogen. It has an atomic number of 1, an atomic mass of 1.008. This is a 0 if you didn't know up here. Okay. Mass number of 1. 1 proton, 0 neutrons, and typically it would have 1 electron. But you can see that it has a plus here. So if there's no number indicated, we're assuming it's 1. So we're losing 1 electron. Why are we losing instead of gaining? If you become more positive by 1, that means you're giving up negativity. You're giving up those negatively charged electrons. So you're losing electrons when you become more positive. Remember, electrons have a negative charge. So if you want to become more positive, you have to give up the negativity. So we have hydrogen, typically would have 1 electron, but we're giving that up. So 1 minus 1 ends up with 0 electrons. The next one's carbon. Carbon has an atomic number of 6, an atomic mass of 12.011. Mass number is 12. There are 6 protons. To get neutrons, you take mass number minus atomic number, so we get 6 neutrons, and it doesn't have a charge, so the number of protons has to equal the number of electrons, 6. Next one, lithium. Lithium has an atomic number of 3. On the periodic table, we can see lithium is 6.941. The mass number is 7. How many protons? 3. How many neutrons? Well, neutrons equals 7 minus 3 to give us 4. And electrons. So typically in an uncharged atom, there's 3 protons, so we would have 3 electrons. However, just like hydrogen up here, we become more positive by 1. Electrons have a negative charge. So if we give up that negativity, we're becoming more positive. So we have to give up 1 electron to become positive by 1. So 3 minus 1 gives us 2 electrons. This next one, chlorine. Chlorine has 17 atomic number. The atomic mass from the periodic table is 35.453. The mass number is this top number here, 35. How many protons? Well, the atomic number is 17, so we have 17 protons. How many neutrons? We do 35 minus 17, and that gives us 18. And in an uncharged atom, the protons would equal the electrons. So uncharged, it would be 17. But we have a charge here, and now it's a minus. So we have minus 1, or 1 minus as our charge. So if we want to become more negative by 1, that means that we're going to have to gain negativity back. So we're going to actually gain electrons to become more negative. So 17 plus 1 gives us 18. The next one's potassium. Potassium has an atomic number of 19. The atomic mass from the periodic table is 39.098. Mass number is this top number here, 39. Protons is going to be equal to the atomic number. Neutrons, you're going to take the mass number minus the atomic number. So we get 20. And there's no charge on here. So the number of protons is going to equal the number of electrons. And then we go to the last one, arsenic. So arsenic on the periodic table is number 33. So if we put this 33 down here, we know 33. The atomic mass from the periodic table is 74.922. And when we round that, it just becomes 75. The number of protons is equal to the atomic number. The number of neutrons is equal to the mass number minus the atomic number. So we do 75 minus 33, and we get 42. And typically, in an uncharged atom, we would have the protons and electrons equal, so we would have 33 electrons. However, you can see this has a 3 minus charge. That means we're becoming more negative by 3. We are adding 3 of those negatively charged electrons. So when you become more negative by 3, you have to add 3 electrons. So this is actually 36 electrons. So take some time to review this table, review how I did the math, my logic and reasoning for calculating things the way they are, and then you'll work through some of this on your homework assignment, and definitely study up on this because you will be asked questions about this type of stuff on the exam.